Hi, so this is lesson 0.6, operations in scientific notation. I know it says adding and subtracting, but we're also going to add multiplying and dividing to this. We are going to first start with adding. Step one is to make sure exponents are the same. We're going to do something what's called, or what I like to call, LARS. Oops. Sorry, I'm using a new tool, so we're going to see how this works. Apparently, it's not working very well. That is, again, LARS. LARS. Left add, right subtract. To shift the decimal and change the exponent if needed. Step two, we're going to add or subtract the decimals. Keep the common exponent. Okay, so let me change maybe this will help. All right, so number one, we're going to look at our exponents and say, oh, well, those are the same, so we're going to keep those. So we're going to have 10 to the second. And then we're going to add our factors. So we're going to add 3.4 and 5.2 to get 8.6 times 10 to the second. And because this is between 1 and 10, we can keep it just like that. Number two, we are going to have to change one of these exponents so that they are the same. So if I like to change one, I like to move one up to make it the same rather and try to be consistent. So in other words, I'm going to move this 6 up to make it 7. And in order to do that, I have to add to that exponent. And if I'm going to add to that exponent, I have to move my decimal to the left. So this 1.1 then becomes 0.11 times 10 to the 7th. Now I can add that to this one right here. So we're going to add 9.5 plus 0.11. I get 9.61. So 9.61 times 10 to the 7th. Again, because 9.61 is between 1 and 10, I don't have to make any more adjustments. Let's look at number 3. Number 3, the exponents are not the same. So I need to make an adjustment to one of them. I'm going to move this one, -5, up. And remember your number line. So if I move -5 up, it's going to become -4. And again, based on LARS, if I add to my exponent to make it -4, that means I need to move my decimal one spot to the left. So I have 0.318, and I'm going to add 7.24 to that. 7.24. So I get 855.7. So 7.558 times 10 to the -4th. Again, it's between 1 and 10, so I do not have to make any more adjustments. We're going to move on to subtraction because it's basically the same idea. Look for your powers of 10. Look at your exponents. In this case, they're the same, so I'm going to keep that power of 10. I'm going to take my factors, and this time I'm going to subtract them. So when I subtract 8.17 minus 2.6, I get 5.56 times 10 to the 4th. Let's look at number 7. Number 7, I'm going to, again, adjust my exponent. I want to move it up, so I'm going to move it up so it becomes -4, which means I need to move this decimal one spot. So I'm going to be subtracting 0.68 times 10 to the negative fourth from 4.2 times 10 to the negative fourth. And when I do that, I get 3.52 times 10 to the negative fourth as my answer. Go ahead and pause the video and you try number 9, 10, 11, and 12. Number 9 was a little tricky because when you adjust your exponent, or if you were to add your exponent and adjust your decimal one spot to the left, you get 0.67 times 10 to the fifth. Well, this number, 0.67, is not between 1 and 10. So we need to move that decimal one space to the right this time to make it 6.7 times 10. Now, because we moved our decimal one space to the right, according to Lars, if we move it to the right, that means we have to subtract from our exponent. So this becomes an exponent of 4. Number 10 is really tricky because notice these exponents, they're not just one number off, they're 3 numbers off. So I have to adjust this kind of like 3 times. If I add 3 to negative 1, I get 2. But if I add 3 to this exponent, I need to move this decimal 3 times. So now I am adding 0.00341 to 8.2. So I get 8.20341 times 10 to the second power as my answer. We have to keep all of these significant digits in our scientific notation. Number 11. Notice the exponents are the same, so we're going to keep those. So we have 10 to the negative 6, sorry about that, times 12.61 after we add. But notice again, this is not between 1 and 10, so we need to adjust that to make it 1.261 times 10. Now, because we moved that decimal to the left one spot, we need to then add to our exponent. So this becomes negative 5. And number 12 is 5.2 times 10 to the 8th. Again, that's 5.2. Multiplying and dividing. Step number one, multiply and divide the numbers. Step 2, you're going to use the product rule from your exponent rules, and we're going to add the exponents when multiplying. With the quotient rule, we're going to subtract the exponents when dividing. Step 3, you're going to use Lars again to adjust the decimal and exponent in the final answer if needed. So number 13, when step 1 says multiply or divide the numbers, they're talking about the factors. Sorry, my pen's not as good as I thought it was going to be. So when we multiply these factors, we get 5.32 times 10. And because we are multiplying powers with the same base of 10, we're going to add those exponents. So we get 10 to the 11th. Number 14, we're going to do the same thing. We're going to multiply our factors to get 6.11 times 10 to the 4th, because we have to add our exponents when multiplying. Down here, we have division. 15 and 16, we have division. So what we're going to do is divide these factors. 6.4 divided by 4.0, we get 1.6 times 10. And this time, because we're dividing, we have to subtract those exponents. So if you remember our integer rules, we have -4 minus 6. If we keep, change, we actually have -4 plus -6, which gives us -10. Number 16, divide your factors. You get 3.1 times 10, and we're going to subtract our exponents again. And we have 5 minus 3, which is 2. This is why we reviewed our decimal rules, because we're working a lot with decimals right now. Go ahead and pause the video and try 1, 2, 3, and 4. For number 1, you should have gotten 4.73 times 10 to the 9th, because you should have added the exponents, multiplied the factors. 4.73 times 10 to the 9th. For number 2, you should have gotten 0.8 times 10 to the 5th. And you should have noticed that this is not between 1 and 10. So we have to move our decimal one spot, and you get 8 times 10. And because I moved it to the right, remember Lars, because I moved it to the right, I have to subtract from my exponent, so I get an exponent of 4. Number 3, you should have gotten 3, that's a 3, times 10 to the -8th. Number 4, you should have gotten 3.68 times 10 to the 17th. This is after adjusting, so when you multiplied, you probably got 36.8, which means you have to move your decimal to the left one time and add to your exponent. Don't forget your summary and at least one question.